So this is an example in solving some applications in linear first order ordinary differential equation. This problem we will be solving something about air circulation. So the problem is like this. In a room containing 20,000 feet cube of air, 600 feet cube of fresh air flows in per minute, and the mixture is exhausted at a rate of 600 cubic feet per minute. So the questions that we need to answer are the following. What is the amount of fresh air, which we denote as y of t, at any time if y of 0 is equal to 0? And after what time will 90% of the air be fresh? So now from the problem, we need now to derive an equation about it. So first, we let y be the amount of fresh air. So at this problem, these are measured in cubic feet. So first, we need to recall that the inflow minus the outflow equals the rate of change. So at this point, or at this example, our equation will have to be then y prime is equal to 600 minus 600 over 20,000 y. So again, we have y as the amount of fresh air in cubic feet. So from the problem, we were given that the amount of air flowing in is 600 cubic feet, while the amount being exhausted or being outflown is 600. So 20,000 came from the amount of air in the room, which is 20,000 feet cubed as stated in the problem. So karon, pwede nato ni ma-rewrite ng ato ang equation as dy over dt, which is also another way of writing y prime, which is equal to 600 minus 600 over 20,000 y. Now that we already obtain an equation, this is already a linear first order ODE. So now we need to solve for the general solution of the equation so that we could answer the necessary questions that we need to answer. So now we have this one as our equation, as I said a while ago, and we have several steps in solving linear equations in first order ODE. So of course, the first step is this one. We need to write the equation in standard form. So in this case, we could rewrite it as dy over dt plus 600 over 20,000 y is equal to 600. So we can simplify this equation as dy over dt plus 0.03y, which is equal to 600. So in this case, we have our pt be equal to 0.03. So next step we have is we need to solve for y of t, which is our integrating factor. So at this case, we just have to. So our step 2, we have mu of t, which is equal to e raised to the integral of p of t dt, which in our case is, as I have said, our p of t is equal to 0.03. So ang ato dayong mu of t or ang atong integrating factor kay mahimo na dayon siyang e raised to 0.03 integral of dt, which is equal to e raised to 0.03t. So the next one is multiply the integrating factor to the original equation. So we are already now at our third step. So we recall that our original equation is dy over dt plus 0.03y, which is equal to 600. So now we need to multiply both sides with the integrating factor. 0.03t e raised to 0.03t. So we have dy over dt times e raised to 0.03t plus 0.03y times e to 0.03t, which is equal to 600 times e raised to 0.03t. So this is it. So the fourth step is that we need to simplify it in this form. So we have d over dt times the integrating factor, which is e raised to 0.03t times y, which is equal to the integrating factor times the f of t, which in this case is 600. So next thing, which is the longer part, is that the fifth step is we need to integrate. And I think we need kinahanglan tag bag-o nga papel para mahimo na siya. Well, so for the fifth step, we need to integrate. To integrate d over dt times e to 0.03t times y, which is equal to e 0.03t times 600. So at this case, we now have d over dt times y times e to 0.03t. Well, I just rewrite lang ako ni siya into this form for beautification and simplification purposes, times e to 0.03t times 600. Integrate both sides. So at this case, this would automatically be y e to 0.03t. So the right side sa atong equation ang medyo na ay trick. So we need to use or we need to let u for us to fully integrate this part of the equation. So in this case, we need to let u be 0.03t. Therefore, du will then become 0.03 dt. So we need to solve or we need to write the equation in terms of dt, since dt man ang given diri. So dt would be equal to du over 0.03. So in return, dapat na mag-multiply og 1 over 0.03 sa atong equation. Integral of e raised to u, since gilat man nato siya nga u, times 600 du na dayon siya, since ato namang gi-apply ang atong gilat u. So therefore, we have y e to 0.03t will now be equal to 1 over 0.03 times, or 600 over 0.03 times e to the u plus c. So mahimo na din siya y times e to 0.03t be equal to 600 over 0.03 times e, ato na din siyang i-substitute og balik, 0.03t plus c. So now we need to rewrite, or ato na siyang i-rewrite in terms of y. So at this case, kinahanglanon nato i-multiply both sides by 1 over e to 0.03t. So same is true here, 1 over e to 0.03t para atong ma-maintain ang equality sa atong equation. So at this case, makancel na siya. So we have y is equal to, so makancel ni siya diri nga part. So mahimo na lang din siya of 600 all over 0.03 plus c times e to the negative 0.03t. Or ma-rewrite na nato siya as tooth sorry, mas ma-rewrite na nato siya as 20,000 plus C times e to the negative 0.03t. So mauna din ni siya ang ato ang general solution. We have already solved our general solution. Again, it was y, which is equal to 20,000 plus c times e raised to negative 0.03t. So now we can answer now a few of our the first question in our problem. So as the first question that was asked kay, what is the amount of fresh air we denote as y of t at any time if our y of 0 is equal to 0. So therefore, we have to use, or we need to solve for a particular solution wherein ang atong y of 0 is equal to 0 as our initial condition. So therefore, we could solve for a particular solution. Thus, we have y of 0 then is equal to 0, which is equal to 20,000 plus c times e raised to negative 0.03t, or in this case 0. Of course, this would give us 1. Therefore, our c then will be equal to negative 20,000. So our particular solution will then be y is equal to 20,000 minus 20,000 times e raised to negative 0.03t, or this could be further simplified as 20,000 times 1 minus e raised to negative 0.03t. So the next question that was asked kay, unsa daw kuno ang time wherein 90% sa air kay mahimong fresh. So before ang atoang given kay natay 20,000 cube or 20,000 feet cube nga air sa room. So ang ipangutana kayo, what time will 90% kay fresh? So therefore, ang ato dayong atong equation or ang atong solution dayon kay mahimo na din siya, or 90% sa hangin kay mahimong fresh if ang atong equation kay mahimong e raised to negative 0.03t will be equal to 0.10. Since 90% man daw ang mahimong fresh, therefore 10% na lang ang dili fresh. So mahimo na lang, for us to solve for t, we need to take the natural logarithm of both sides. So we have ln of that and ln of this one. So mahimo din siyang negative 0.03t is equal to the natural logarithm of 0.1. So solving for t by simple mathematics, we have ln of 0.10 all over negative 0.03. So we can solve it, which is approximately 77 minutes. So therefore, it will take 77 minutes for the air, or for 90% of the air to become fresh. So again, we need to review some important answers to our problem. So we have this one as our particular solution, and this one as a general solution of this problem. So I hope you find this helpful, and thank you.